And good morning. And given the seasonality, I think I'll add season's greetings to that. Welcome to the FDW Audio-Technica presentation on wireless solutions. And I'm glad you tuned in for us today because what a great topic and a great time to be doing this with all the changes that have occurred. The topic says it all. We're really looking for solutions. It's gotten more difficult, and it's also a topic that's full of changes. So today we're going to talk about some of the solutions, and Audio-Technica will be helping us with that. Before I get underway, though, a couple of things to pass along in the way of housekeeping and give people a few more minutes to join us. So in the housekeeping department, I wanted to pass along that this is a recorded webinar, which means that we will be available for anybody who has friends or coworkers that are not able to tune in and catch this in live time. Of course, nowadays, the idea is to be able to present this whenever you want it. So that's available whenever you do want it. Tell your friends and associates if you found this of use and pass it along, and they can find that on the FDW website. Also, we will be giving you the opportunity to ask questions, and the way that will work is just utilize the GoToMeeting question resource. Type us the questions. I'll accumulate those during the webinar, and in some cases we get multiple questions very related to the same topic, so I may paraphrase. If you don't hear your exact question, it may mean that I'm combining two or three together, but I'll present that to our question and answer session at the end. And also, while we're talking about the end of it, please don't leave the webinar without completing the survey. It's just a 3-question survey at the end, and before you exit, it would be very helpful to us if you would fill that out. That helps us keep these webinars on track and make them better, and it's also a great chance if you want to submit a topic for something you'd like us to focus on in the future. And with that, let me introduce our presenter today. We're very lucky to have a very astute presenter from Audio-Technica to help talk about wireless solutions. And there's his picture. I see Dan now on the screen. Dan Pelletier from Audio-Technica. We've been enjoying having a pre-webinar conversation about his experience in the audio industry. And, you know, almost everybody that we talk to in the audio industry has another life. And his other life, he plays bass, and as he describes it, a guitar player who plays bass in a band. And so he has fun with audio. It's not just a dreary job. It is, in fact, his life. So, Dan, welcome to the webinar today. It's going to be kind of a fun conversation, I think.
Yeah, and I agree, and thank you for that, Kevin. And I want to thank FDW again for putting this on, and I want to thank everybody else, of course, for attending and for your time today.
And also, Dan, I want to
Yeah,
thank Audio-Technica for providing us some demos of some really cool headsets. Before we
yeah.
launch into our discussion of wireless solutions, I want to pass this along because now you're not wearing it, but I'm wearing it. This is a brand new headset. I didn't write down the model number. You probably know what it is, Dan. It's the 2-ear version of it.
Yes, is the
Uh,
BPHS2. It's a new broadcast headset.
And to my way of thinking, and I've worn quite a few of these over the years. I used to be a broadcaster a long time ago and had to wear these. Oftentimes they were not very comfortable. I could wear this all day. This is great, and
Yeah.
microphone boom could be worn on the left or right ear. It's really quite nice. Normally we don't use headsets for this program. We speak into regular microphones, and that always carries with it a certain element of, gee, I hope they don't do any pages that around the building here while we're doing this, and we have to be concerned about the acoustic environment so it doesn't sound too much like we're in a can. This is a great solution. So please pass along to Audio-Technica that we have no intention of sending these back. We're going to use this from now on.
I could pass that along. And
There we
maybe
go.
a little quick tidbit about those two is that they have the same driver as our new M60 headphones. And they sound quite good. I think
That's why they sound so good. Yeah, that
I think
explains
the
it.
M50s or the M60s might have jumped the M50s for me. They sound pretty fantastic.
Well, they truly do. They're very comfortable and sound great. And but that's not our topic today. We're going to talk about wireless solutions. And yeah, what a good time to be talking about this. We have
Oh
a lot of
yeah.
people out there using wireless microphones, and solutions are what they need. So, Dan, I'll back out of the way and let you get on with this. But thank you for joining us.
Yeah, well, thanks for putting this on again, and again, thank you everyone for your time today. Diving right into this, we wanted to let everybody know that starting on November 1st of this year, we have formed a strategic partnership with RF Venue. So now we are a distributor for RF Venue products, and Where that changes for Audio-Technica is that instead of recommending, if you're familiar with the DA49 distribution antenna distribution system, we're now going to be recommending a distro 4. So in terms of FDW though, since you're a customer, you wouldn't necessarily be asking for a DA49, you'd be asking for a distro 4 in place of that. And there's some other offerings like the DFIN W, DFIN B, an assortment of RF accessories that I think are really going to elevate Audio-Technica's standing in the wireless world. So I wanted to cover some RF transmission overview, and basically, since there's going to be a copy of this, I'm going to breeze over a lot of this for time's sake. What really I kind of want to focus on is that this is analog wireless has been developed for years. I mean, we're well into 90 years of it being developed, and because of that, analog circuitry is pretty simple, inexpensive. It's easy to build. So in analog transmission, if you are able to look at if you look at the image on the left, you see the signal, that's the audio signal, and then you see the carrier wave, and those are combined and then broadcast. So in the image on the right, you see the audio signal on the top, you see the AM signal and the FM signal below. And the AM signal, what's neat about this graphic is that the signal is analogous to the AM broadcast, to the amplitude of the broadcast, and thus the amplitude is modulated based on the audio signal. In FM, though, it's a little bit different. So if you see below that, if you look at it's going to be a little bit difficult to track along, but the positive portion of the audio wave, and then you look at the frequency, how that's modulated relative to the positive and the negative. The positive, the waves get tighter, and the negative pressure, if you will, the waves go further apart. So the frequency is modulated. And what's good about this is, at least in terms of FM, is FM really resolved an issue of interference for AM. If you're driving in your car and you hear a lightning strike, there's a lightning strike anywhere, you hear that static, that in the AM signal, but you don't get that in FM. So FM really cleaned up. It was the next step in reducing the amount of interference that you get into a signal. So the disadvantage, though, of analog is that you really do need a good signal to noise ratio. It's typically about you want 30 dB of desired signal to undesired signal. So if you look at the image on the left, you have a good signal to noise ratio, and thus you have a nice image. But when the signal to noise starts to get a little wonky, if you don't have good enough signal and noise, then really, in this case, the image quality goes down. But what you're really looking at is reduced dynamic range, and your audio quality can suffer for it. But with digital, the difference is it's not the difference between digital analog and digital microphones it's not necessarily based on the method used to impress the information. It's more so on the format. So now the signal, in this case, on the left, the audio signal is digital. So it's sampled ones and zeros, and that's combined, but it's still over an FM transmission. And the advantage to this is that there's some error correction. Your signal to noise doesn't have to be as good, and it's reduced intermodulation, which is another benefit of digital. But the disadvantages is that it's still relatively new. It's a little bit more difficult to manufacture. It's can be more expensive, and you get latencyy. So if you see the image on the left, you still have a good enough signal to noise ratio where you get the full signal. But if you don't, I mean, as with any RF signal, if you don't have a good signal to noise, then you're susceptible to drop out. So that being said, any wireless operation is really continually, it's requiring more expertise. I remember when I started, in a way you can, not to pull away from frequency coordination, but you could be a little bit more liberal with it. You didn't really have to be so tight with your planning. I knew plenty of areas, plenty of people who were not really paying specific attention to their frequency coordination. But what really wireless is becoming is it's less becoming about range and more about controlling your environment. So if you see the image again on the left, I want to say that that's Willow Creek Church in Chicago, or in the Chicago area. And in this scenario, you're going to need range because front of house is going to be located at the back. Whereas if you look at the image on the right, which is a classroom, you might not want the range. You might want the RF signal to be confined to just that area. And thus what you might be able to do is fit more frequencies in a given area. We'll talk about that in a little bit. Okay, so some other wavelength considerations. So much like audio frequencies, radio frequencies have a shorter wavelength. So a 500 megahertz wavelength is 23.2 inches versus 2.4, which is 4.8 inches. So it's 79% smaller in terms of its waveform. And higher frequencies, they experience more loss traveling through the air. So you have a 13 dB difference, which could be significant. And finally, considering all of this, the higher the frequency, the less penetrating power it has. And so you see 500 megahertz at 8 dB through it's 8 dB through an 8-inch concrete block, but the attenuation is 12 dB on a 2.4 gigahertz signal. So that's a 30% reduction in signal strength. So 2.4 doesn't travel through walls very well. So that's kind of in a way where we come in with 600 megahertz. And I know we're kind of beating this all to death, but the lower the frequency, the better penetrating power it has. And thus, the telecoms wanted it. So if you look at the Spectrum Act of 2012, that's what really paved the way for all of this. And when you ask why, well, not only did the telecoms want it, but it was going to deposit $7 billion into the U.S. Treasury. So it seemed attractive to everybody. So Congress authorized it, and they did it under the Spectrum Act, or the Middle Class Relief Act. And that was able to pay, this reverse auction was able to pay for some of that, and thus the $7 billion in the Treasury. So the other thing that makes this more complicated is that what's going on with 600 megahertz directly impacts 400 and 500 megahertz. And below that image is from the FCC, and it shows a phase schedule when television stations have up to the end of their phase to get out of 600 megahertz and either go offline or move to another frequency. And that's moving. It means that they're going to 400 and 500. So everything got way more congested. It wasn't like in a way where like 600 megahertz is going away, but then 500 is wide open. And with this, what makes this a little bit more complicated is that a TV station can get out before their phase, and if T-Mobile wants them out even sooner than that, they can even incentivize them. But we're in constant contact with T-Mobile. We know when they're going to be putting channels online, and we can coordinate frequencies around that. So again, very quickly, this is what pre-600 megahertz transition looked like. If you look at the area, I'm going to point this out here on the right. This is 600 megahertz right here. And that was available, but now what's available is this, and this right here is the duplex gap, which there's a limited availability in. And if you do have a 600 megahertz system and you do start taking hits, you can tune a few of your channels in there, and that might buy you some time relative to a end user buyback program or rebate program, which we have and we'll cover later. So in lieu of this 600 megahertz transition, everybody really wants to be able to maintain their channel counts and of course grow. So that being said, what products are now offered by AT that can make the best use of the RF environment that you have to operate in? And the first thing we're going to cover is System 10. This is our digital system. We've been developing this for quite some time now. The first iteration of this came out in 2012. And that was the basic version, but we're going to cover the pro version that's been out for a few years now. This is a duplex system. So you have the transmitters and the receivers are communicating with each other back and forth. And they're scanning 2.4 fully every 8 seconds just to kind of see where everything lives, and the frequencies will hop or move when they need to. The System 10 has 3 kinds of diversity. You have the frequency diversity, so it's broadcasting on 2 different frequencies simultaneously. But those frequencies are also broadcast at different times, and they're about one digital frame, I think 40 microseconds apart. So if the system does need to switch a frequency, it could do so without anybody noticing. And then space diversity, which is not new. That's, you have two antennas, they are separated, so the potential for dropout is less than it would be with just a single antenna. That's common throughout the industry. But then the question is, it's a 2.4 gigahertz system. Then again, how does it work with Wi-Fi? Well, the answer is, in most cases, pretty well. So on the left, you have your Cisco Enterprise Network. That's your Wi-Fi signal. And then on the left, you have one transmitter, if you will, of system 10. And you see your two lobes there. Those are your frequencies. And I couldn't tell you which one was which. I don't know which one is the primary or the secondary. But then if you look at the image on the right, that's 8 channels of System 10 Pro with that Cisco Wi-Fi network. So it'll scan again and avoid trouble scenarios. A nice thing about this too is that the remote antenna is actually the receiver. That's called the RU13, and you can remote it with Cat5 cable. And if you've ever tried remoting an antenna with plenty of other systems and using RG8, the bend radius on RG8 is not it's not desirable, we'll say, and RG8 is quite expensive as compared to Cat5. Cat5 is I would say pennies on the dollar comparatively. So you can remote each individual receiver. And the reason why you need to remote the receiver is because they are uniquely linked to the transmitter. So there's no distribution for this system, but they do come with mounting brackets, as you can see on the right, and you can join all of those together. And if you use I could plug Krylon paint for plastic, so you can blend this into any wall, I'd say fairly well. So with System 10, you think that it's 10 systems simultaneously, but it's really broadcasting 20 frequencies. And in order to coordinate all of this, they have to be linked together. That way, one system, a primary, doesn't land on another system's primary or another secondary, because that can create some additional latency. It's going to create a lot more time for the system to try to jump around and try to find a frequency that it can land on, that it could live. So you got to link these systems together. And then it has all the standard output connections for your analog audio, your balanced connections and your unbalanced connections. You have a ground lift and you have your volume control. Here's some of our transmitter offerings. So we see we have a standard body pack. We have a handheld, and the handheld's sound is similar to the Audio-Technica ATM 510. It's not that element; it's its own element, but it's quite similar. It's pretty. Audio-Technica is generally known for brighter sounding elements, and that gives it a little bit more clarity, in my opinion. So that's what you'd be getting with this handheld. There's also a boundary option, and there's a gooseneck option. The mic feature there is the ES935 ML6, and that is not included with this. We also have some different form factors. One that we've been covering is System 10 Pro. That's the dual channel system. And we also have a camera mountable system and a basic receiver. And to share a success story about this, so going back, keeping this in mind, this is all about controlling your environment. That System 10, we got a call from a local high school, and they wanted to do 32 channels. And at the time, we thought a traditional FM analog system is probably not going to work well, especially because of the amount of range that you have with the system. So you put yourself in the scenario, the instructor there on the right, if they have to use the restroom and they walk down the hall and they forget to turn off their transmitter, I think that would end up being a fairly unpleasant scenario for the instructor. But we brought System 10 in and our analyzers, and found that every third room in, so you have your primary room, 2 rooms in between, and then that would be your third room, or you could, depending on how you look at, your 4th room over. At that room, we can get another set of 10 channels. And so we thought to ourselves, this is going to work. And we were in a place where the Wi-Fi network was very well defined. There weren't too many WAPs. It was just the right amount, and we ended up being pretty successful at it. It's still there to this day. And the nice thing is that it was pretty affordable to the end user. So they got 32 channels out of a 16 channel system, and the end user cost was under 14 grand. So I would say that that's class leading, but I would probably say that would be more for you to decide. And moving right along out of that into some analog wireless, our new 3000 series offering. So the 3000 series, we've had it out for a while, but I would say that it needed a significant update, and I believe that we got that with this. And here's just the general overview. We have your standard body pack. We have a T3202, that's the transmitter, but we have removable capsules now, which we'll cover in shortly here. If you're familiar at all with 3000 series, you might know about the I band, the C band, and the D band. And although you can correlate those to a frequency bandwidth, 600 being D band, C being 500 megahertz, and I band being upper 4, lower 5, I don't think anybody could tell you what those letters actually meant. I think they were arbitrary. So we came up with a new scheme to give a little bit more rhyme and reason. And how we did that is the first letter represents where the frequency starts, and the second letter represents where the frequency ends. And then there's a corresponding number depending on how many of these that we have populated. So if you see here with the example, DF1 starts in D400, but ends in F500, actually in the duplex gap. Now this is not a 3000 series thing. This will be a 5000 series thing when it's available. But if you look below it, you'll see DE2 and EE1, and that's what we're going to focus on here. So for 3000 series, you have DE2, starts in D400, ends in E500, and then this got number 2. And then same with EE1. On average, you can do 6 to 8 channels per open TV channel per 6 megs. So that gives us a maximum possible of 40 per band, or 80 total. Now, that would be in maybe the middle of Alaska, where there's an interference-free, completely clean RF environment. Believe it or not, they still do exist, but they are rare. So you can get potential of 80 online, and we'll discuss that relative to its price point in a little bit here. Some of the new features related to it is the auto scan feature has been updated. So when you scan, there's a low setting, a normal setting, and a high setting. In the low setting, it's the minimum channels, but it's going to be the lowest potential for interference and noise. Normal is what it's set to out of the box. And then high is your maximum channels, but the noise floor reference is going to be a little bit lower, where it's going to sense some noise and it'll try to operate even though that there might be a slightly undesired signal to noise ratio, but you can still be able to get your maximum amount of channels. Within that, there are 10 default scan groups, but 2 user definable groups. And what you can do with these is, if you get a coordinated frequency plan from an Audio-Technica applications engineer, you can input those into the user definable group. And a nice thing about the 3000 series with the receiver is that you can lock it out and kind of make it a little bit more difficult for the end user to switch to another frequency. Stop me if you've heard this one before, or if you've dealt with this. You end up coordinating frequencies for, let's say, a house of worship. I've done that on plenty of occasions. I used to be the front of house guy for a few churches for plenty of years, and the pastor or the minister would forget to unmute their microphone, and then what they think the issue is a frequency issue. So then they go to the receiver and they change a frequency, and then that messes up the coordination for the rest of the systems, and they wonder why they're continuing to experience issues. Well, you can lock it out to a degree, so that way the end user would only be able to access the user definable scan group. So that's kind of a nice feature, in my opinion. There's also an auto squelch setting. It's set to automatic out of the box, but if you want to, you can set it to manual, and you have a squelch range of 1 to 13. The lower the number, the lower the reference. The higher the number, the higher the reference. So being right down the middle in this case, you're looking at the red line relative to this might be at number 7, respectively. Not new to the industry, but new for Audio-Technica, IR sync. So you would program everything at the receive end and then push that from the receiver using the IR sync window to the body pack or to the handheld. Two different screens. So you have a standard view and you have a performance view. And the standard view gives you a lot of telemetry, but going to the performance view, something that I'm going to call out here is if you can see this line right here, that's called a minimum RF hold. And what the minimum RF hold could be used for would be, something like this. So you have a theater, a high school theater, and you have a few of these, let's say you have 8 channels of this going, and you have your antenna set up and you want to just do a walkout test where somebody has their body pack and they walk around the stage and you want to check it for dropout. What this will tell you is that if there's any point at which they are getting maybe a potential for getting a dropout, the RF is going to hold at its minimum. And what that could tell you, at least applicatively, is that you might want to change, you might want to remote the antennas. You might want to change the position of the antennas, and that way you can reduce the potential for dropout. Again, not new for the industry, but new for Audio-Technica is that we have interchangeable capsules now. And we're using the industry standard threading, which is also used by Shure, Sony, and Line 6. So if you somebody really likes the sound, they like how AT wireless performs, but they really want to use a 58, well, then you'd be able to do that, or vice versa. Our capsules will work with Shure wireless systems that you can switch out a capsule for. We also have a new connector. So this is a little bit of a pain point for AT. And subsequently for our customers. So the previous connection for 3000 series was called the CW connector. It was a 4-pin Hirose. And it did have a decent amount of play in the connection itself. So you plug this in. It was a latching connector. When you plug it in, and the fact that it could wiggle back and forth kind of left a bad taste in the mouths of some customers, where just the perception alone is like this is not seated very well, it could break. Even though that was pretty rare, the perception was enough for us to make the change. So we've switched over to a screw down type connector. It's a lot better. It's a lot more, I hate using the word because it's kind of overused, but it's a lot more robust. And you plug this thing in, it's keyed. There's only one way you can key it in. I've tried stripping it out. You really can't. And it's very secure. But then the question is, well, what if I have a microphone with a CW connector? Well, if you have a legacy Audio-Technica microphone with a CW connection, then you would use the AT-CWCH. And this is compatible with most other manufacturers that are still using the CW connection, namely Countryman. But people really don't like using a dongle, and I understand why, but this is a solution for that. Nonetheless, something you could do with the transmitter is you can flip the clip. So if you flip the clip, if you see the image on the right, then the dongle is really only hanging down, and then the rest of the microphone is going up, instead of with the connection hanging up, then the connection's going up and then down and then back up. So that's going to put a little bit of stress on the connector. In this case, though, you can flip the clip. There's an LED indication on the transmitter, both on the body pack and on the handheld. Those can be disabled. Additionally, we have a toggle switch, and this was something that was very highly requested by the House of Worship market, where you can toggle mute, and you have an indicator. I'm going to point out this indicator here on the right to say what position the toggle switch is in. This can also be disabled if you would like. And then there's a multifunction switch, and this is, I believe, unique to Audio-Technica still. And what the multifunction switch can do, one of 4 things, and that's either a mute, so it could be used as a mute, and that's if you have the toggle. Let's say you don't want to use the toggle switch, you want to use the multifunction as a mute. You can do that. You can also have a forced mute. A forced mute is when you have the transmitter locked out, so the user would not be able to switch frequencies, change RF transmit power, but they still needed a mute. So in this case, everything is locked out but the mute. Then my 2 favorite features. So you have RF off and backup frequency, and the backup frequency is probably the gem of things that it could do. So you'd program the frequency, the backup at the receive end, IR sync it then to the transmitter, and then if there's any issue, the end user, the user can switch to the backup frequency. So the example of that would be, I've had plenty of times where, well, not plenty, but enough where a pastor would be speaking and they start taking RF hits, and then we either have to switch out the body pack. This is, a few years back, and try with a different frequency. Well, in this case, if the pastor's speaking, you hear some pops, you're getting some interference. They could stop, take a drink. That was kind of weird. And hit the backup button or hit the multifunction button. And then within a certain amount of time, you'll have, it's about 8 seconds, then the end user will be on the backup frequency. RF off, I like to put this into the James Stoffo bread pan kind of thing, where if you're operating a lot of wireless systems, and you get transmitters next to each other, transmitters, the closer they get, they start creating intermods. And if they create intermods and that gets into your audio, it sounds terrible, right? So the solution for that in the past for a lot of A1s was to put transmitters in bread pans. Well, in this case, you can set the switch to RF off, and that'll mute the RF signal, but it'll mute the audio and the RF signal. So instead of using bread pans, or you can use them in conjunction with bread pans if you like, you can set it to RF off. We also have charging now. We have the CHG3 and the CHG3N. I should have put the CHG in there, but the N is the network one. And the idea behind that is that you can monitor battery life on a system. And you only need one network version per gang of 5. You can do 5 max. So in this case, the network one would be the first charger, and then the other 4 will be non-network versions. The thing to really note about this is that it is a piecemeal system. This is a la carte. So how you would order this, let's say you needed 3 chargers, and you didn't need them on the network. So you would order 3 CHG3s, 2 joining plates. Those are they're going to link these chargers together, and then 1 power supply, the SA1230XA. Or if you wanted them on the network, then you'd have 1 CHG3N, 2 CHG3s, and 2 8687s, and then 1 power supply. And I didn't note this, but if the transmitters are turned on, if you drop them into the charger with alkaline batteries, then they're not going to charge that transmitter. It's going to shut off that part of the bay. But another thing is that it'll turn off the transmitter. So if you're using nickel metal hydride batteries, the recommended is 1900 or higher. I'm typically recommending 2000, 2400 is also pretty prevalent. Then you drop those in, and it's going to turn off the transmitter immediately. On alkaline, you're going to get about 9 hours, and on a nickel metal hydride, you're going to get a little bit more. So an improvement from Audio-Technica standpoint. It is compatible. The 3000 series is compatible with RFNU products distributed by Audio-Technica. So if we're going to be distributing it, then it will be compatible. But you're also going to want to talk to your FDW sales engineer, of course, just to make certain. We are going to offer we're still going to offer the A49s. Those are the paddle antennas, but we are also going to be offering the DFIN, just to kind of throw that out there. It is compatible with legacy AT, with some legacy AT antenna or RF accessories like the DA49. We also have a wideband booster, and there's a joining plate that's not included. That's the AT8631, and includes the rack ears, but it does not include the joining plate. Some additional features is that you have a filtered antenna input. That's pretty nice. So it's filtered to the bandwidth. And what that's going to do is that's going to keep intermods from other frequency bands out. Metal transmitters. Before we had plastic, and we've upgraded them to metal. OLED screen, so they're much easier to read. You still have antenna power. You have a ground lift switch, balance and unbalanced connections, and then switchable transmit power. So that has not changed. Here's some of the pricing related to this. So that's what I wanted to kind of touch on, is that at this price point, I believe that it's, again, class leading. So to be able to get 40 channels online, at least the potential, you're almost looking at a system that's around $800 to $900 a channel. So you can if you will, you can kind of value engineer with Audio-Technica, which we'll talk about in a little bit here again. The the cost of the capsules are the cost of their wired equivalent. So the C510, which is the capsule 510, is equivalent to the ATM 510 capsule. Here's just a comparison between the 3rd generation and the 4th generation. So because of that, you're going to get PDF copies of this as well, so you can reference that if you need to. And then the other question was, well, with 4000 series, we've discontinued 4000 series, and a big reason for that is because we rolled a lot of the features from 4000 series that would have been in 4000 series and 3000 series. So if you did like 4000 series, 3000 series would be the replacement and the way to go for that. And then a success story about 3000 series. So back in late August, we went to New York City to war game 24 channels. And essentially what that means is we had 24 systems going, and we coordinated frequencies, turned off a transmitter, one transmitter at a time, to see if we were getting any chatter. And we found out that we were able to get 24 channels online, but the potential was for 32 because we didn't bring enough DE2 samples. To go back, if you look at our positioning too, we were a quarter of a mile away from the Bank of America Tower on the 9th floor of a building. So I mean, we were in the thick of it. And to be able to get 24 online successfully, but the potential for 32 in New York City is, I think, quite significant for a wireless system. That was our location. I did the walkout test with this, and on 10 milliwatt, I was able to walk the block. But I did get some dropout, but on high power on 30 milliwatt, I didn't get a dropout at all. So that made it, I frequently say this, as an applications engineer, our team frequently moves from skepticism to optimism about our product. We're not really entirely certain. We have an idea, we come up with a hypothesis, we test it out. And when it ends up exceeding our expectation, it makes it a lot easier for us to evangelize the product. So we were very satisfied with the results of 3000 series. Some quick tips for successful operation. Use 50 ohm antenna cable. Generally operate on low power. Antenna boosters, you want to, if you're going to use them at 125 feet and start them at low power first. We can discuss that in further detail if you want to give me a call or send me an email. We can discuss that on an application basis. And a properly configured antenna distribution system can make or break an install. You can have clean frequencies, but if your distribution is not set up properly, you're not going to get your frequencies. Quarter wave antennas can't be remoted. Probably already know that, but they're monopole. So you'd either need a half wave or you need some kind of dipole antenna like a paddle or a half wave whip. You want to keep wireless microphone transmitters separated by 3 feet from each other. I'd say that's a little maybe too conservative. You could probably get about you can probably go 1.5 feet. IEM transmitters and microphone receivers, along with IEM antennas and wireless microphone antennas, they should really be kept separate by 3 to 6 feet at least, because just as with audio, RF is a signal and noise game. And if you have IEM transmitters next to my wireless microphone receivers, well, they can start to chat with each other, and that's something that you don't want. When scanning for frequencies, use only one scan group. So from Audio-Technica, scan groups 9 and 10 for 3000 are going to be the highest ones. But if you're in DE2, then you're going to want to stick everything in DE2. And I'm sorry, if you're in DE2 and you select scan group number 9, one frequency from scan group 9, then all of the frequencies in DE2 should be scan group 9. And same thing with EE1. If you end up picking scan group 10, then all of those frequencies should be in scan group number 10. That's on a per bandwidth basis. IES and Workbench, other reputable IMD calculators, they're good, but they only get you so far. And they get you so far as how you're able to use them. But they also, since you're not on site, that presents another problem. And in that case, you could use a wave tower from RF Venue to send that device to the location. You can monitor that, and you can plug that information into frequency coordination software. And where wave tower exceeds my expectation in this is that in my IMD calculator, we're using IES, it missed channel 16 here. And Wave Tower said that this is enough of an issue where you can experience problems, and that's where Wave Tower has been very successful for me in terms of my coordination, and that was the channel that was missed. Future things from Audio-Technica, one of them is RF coordination software. That should be out hopefully in a few months here. And again, the 600 megahertz rebate program. So ours is going through March 31st, 2019. I believe that this is going to be extended. Don't hold me to it. That's just a gut feeling. But at least as of right now, if you want to switch to an Audio-Technica system, it really depends on what you're getting, not what you have. So if you have a 2000 series that's in 600 megs and you want to get a 3000 series, you're going to get $75 a channel. We also have an installed sound support app available for iOS. But why Audio-Technica? Intelligible audio, transducer consistency. Our microphones are used at the Olympics for that reason. Same for quality control. They're durable and reliable. Price is often a feature. So kind of where I like to say where Audio-Technica likes to live is that if you're doing a job and somebody says I need 15 channels of wireless and a digital mixer, and I'm on a budget, well, Audio-Technica, at least compared to some of our competitors, it could be up to a $4,500 difference for a, or even more for a 15-channel wireless system. So that could buy you a pretty nice digital mixer. And if you have any questions, again, related to that, you can contact any of us, any of the three applications engineers at aeteam@atus.com. So it has a lot, it's like drinking water from a fire hydrant, but are there any questions?
Yeah, Dan, we got one early on here, and,
Okay.
and you started talking about it during the course of the presentation, but I think a little more detail. One of the listeners asked if there was a reliable database, or it isn't a database so much as just, is there a place to go get the latest information geographically on what T-Mobile and the other new owners of the spectrum are lighting up and doing their tests? Basically, they're interested to know what's going on in my area. When do I have to really be out of the pool?
T-Mobile has a mailer that I believe you can sign up for that'll tell you when they're moving. But we have some extra tools here, at least the applications engineering team does, that's related to that. And to put this kind of into a little bit further perspective, when I give a frequency plan, I account for the current environment and the future environment. So I say, this is what you can get now, because if somebody's making a purchase, it's got to work now and later. So I take into account all of that, and I give you a frequency plan that has a strong likelihood of working both pre and post transition. So you can always lean on our team as a resource related to that. And furthermore, of course, you can rely on your FDW sales engineer for that as well.
Very important part, and that does happen here a lot. We get a lot of people who understand the concept of what's going on with the repack up to a point, but I think the part that they may be missing is that it is not a before and after. There really is a before and during and after scenario in terms of the RF frequencies. The broadcasters are undergoing quite a game of musical chairs here. And so there are frequencies that are going to be available. There are frequencies that are going to get busy, and then they're not going to be busy later. It's just, it's much like, I always equate it to watching defragmentation on a hard drive. It's just the little dots are moving, and if you're in the process of trying to use frequencies while the dots are moving, you really do need to do frequency scans. And what are your thoughts on using some of the handheld dedicated? They've become quite inexpensive now. Some of the spectrum analyzers. Generally, they were very untouchable many years ago. Now you can get spectrum analyzers for a few $100s. Are they worthwhile?
Yeah, that's correct. And there's one. I hope it's not too premature in talking about this, but RF Venue is, either it's out or it will be coming out, where they have a handheld spectrum analyzer that's pretty neat. And they are becoming more affordable, and I think this one's going to be a very nice solution for any on-site spectrum analyzing.
Very good. And I'll pass along a tip that's been personally useful. A lot of times when people do that, they neglect to consider the position of their antennas. And my suggestion in that regard is
Yeah.
if you do have a dedicated spectrum analyzer, or certainly if you're using one of the radios that does have spectrum analyzer built into it, but if you're using a dedicated spectrum analyzer, a handheld or whatever, either place it next to, or even better, if you can actually hook up the receiving antennas you use with your receivers to the spectrum analyzer, you're going to see exactly the picture of what they see. It
Yeah,
isn't
that's
really
a
so
very
much
good
of
point.
what's happening in your area as much as it's what is my antenna actually picking up. There's a TV station out there, but if there's enough concrete, it's been knocked down by the walls. You need to know that, and that's the easiest way to do it is just hook up the antennas you normally use.
Yeah, monitor your environment the way your environment is being monitored, and then you should have a more successful result in finding out what's available.
Absolutely. And the other one that always comes up on a very practical basis is it's one thing to know what's around you. It's even more important to know in terms of vectors what direction are they coming from. I had a
Yeah.
church that was pointing a very directional antenna towards the altar, and they had stained glass behind the altar. And if you went outside in the parking lot, you could see the problem. It was pointing at a multi-tower affair. All the
Yeah.
RF in the entire county was just in that line. It's like you don't want to point in that direction. You need to find a different receive location so you can point at a 90-degree angle to the path that you were pointing because you were pointing right at the antennas, at the source of the interference. And the other question that we got in kind of relates to that, which is why I went through all that. You had mentioned and you kind of alluded to the fact that be very careful about using the antenna preamplifiers, the boosters, unless you're compensating for signal loss. And I think you said 125 feet. Can you touch on
Yeah.
that a little bit more and what some of the issues are when you start to preamplify the antennas on the
Okay,
receive side?
that's great. So related to that is RF signals can be overdriven, and if they're overdriven, the result is not positive. It's quite negative. So what you need with RF is just a good signal to noise ratio. You kind of want to this might sound controversial, but I heard it from some significant RF experts from multiple manufacturers. And you don't want to think about RF in terms of unity. It should be less than unity because if you overdrive it, then you can get some dropout, you can get some distortion. It's like it's too much. So what an RF booster really is going to do is going to make up more so for line loss in a cable. RG8 has a significant amount of line loss. We'll just say at 100 feet, this is rough. At about 100 feet, you have at 550 megahertz, your signal could be down as much as 6 dB, which could be 50%. So having a booster really at about 125 to 150 feet to make up for some of that line loss can make the difference.
Absolutely, that's perfect. A very good explanation of why you need to be careful of that. It isn't going to help you when you start to splatter your front end and desensitize it. So, Dan, thank you very much. Those are the questions that came in, and we expounded on some topics, even went beyond those. So I think that's useful. And Dan is a resource that we can tap into. So if you have questions that come up with your installation, or you think of something after this, or you're involved in doing an installation, you have troubles, certainly contact us here at FDW. And when the going gets tough, we'll reach out to Dan for some help on that. Dan, thank you for joining us. As
Yeah.
usual, some new information and some great illustrations of some concepts that are oftentimes hard to visualize. So thank you very much. And once
Yeah. Thank
again,
you, Kevin.
the model number on the headset that I'm wearing here, what did you say the model number was on
The
this?
BPHS2.
Wonderful. Once again, my thanks to Audio-Technica, and we wouldn't just be saying that for no good reason. It is a good problem solver, and so in this application, it works great, much like all of your products. Dan, thanks
Thank
for
you.
joining us.
Yeah, thank you, Kevin. Thank you, Jim. Thank you to everybody at FDW, and I personally want to wish everybody a happy holidays, not just from Audio-Technica, but from myself.
Oh, absolutely. Both ways on that. And folks, please do fill out those surveys on the way out. Thank you very much. You'll be doing us a favor. Thank you.
Thank you, everyone.